All right, we start the stochastic processes. Okay, so this is the material we are using among the lecture notes. This JEX stochastic 2015, and it's much simpler, or the way it has been structured I think is sequential, so we'll go through that. Okay, so this is the material we'll be using in the stochastic class, so make sure the rest of the materials are there so you can refer to them, but I think this will be good for the lectures. Okay, so Yao Ayekple, he's the one who did this stochastic. He did it for actuarial science, and yeah, it's a 3 credit hour course. So these are the things we need to go through. Stochastic 1, you need to know some elements of probability theory. Okay, know what a random experiment is, sample space, all right, know events, sigma algebra, measurable space, probability space. Those are the basic things you need to know, and from there you have to know what a random variables are, right? um, Actually, we won't be going into this, not seriously, we won't go through the random variables because I think it's fairly known. So we would go and start our stochastic process. Right, so remember that this part, this section is cancelled off. Right, we will have lectures on this one, so we'll have lectures on the first part, which is some element of probability theory, because we will need that probability theory in there, even though we might need this ones, but we won't go through. So we'll kindly go through this. All right, start the stochastic process, look at the discrete time process, continuous time process, and then um, some little overview on the random walk. Look at Markov property or Markov process, and then yeah, hitting probabilities and stuff. Okay, so let's start. So this is the first lecture in stochastic process, and we are looking at some element of probability theory. Okay, so the first thing we are talking about is a random experiment. Remember that in stochastic processes, the phenomena we are going to observe is random. Okay, it's something that comes from a random experiment. So we say that a random experiment definition, a physical situation whose outcome cannot be predicted until it is observed. Right, so any experiment that you can't tell the person, okay, this is what is going to come. Okay, so you would only see the outcome after performing the experiment. Then that kind of experiment is called a random experiment. Okay, so example is tossing a coin or rolling a die. So when you're tossing a coin, there are two possibilities, so you can't be sure which one will come. Okay, so it's random. When you are rolling a die, there are 6 possible outcomes, so you won't be sure which of them is probably coming. Probably you can guess and you'll be coincidentally correct, but that is not what it is. Okay, it is the fact that there is that randomness in there that makes predictions very difficult in random experiment. So in stochastic process, we are interested in random experiment. There should be that randomness in any experiment that is being performed. Okay, all right. So when you do a random experiment, okay, so you do a random experiment. When you do a random experiment, so your experiment is random, okay, and then you get an outcome. All right, there is some outcome. which probably will be like anything that can happen. Okay, so the fact that this outcome will change, this outcome changes, okay, we say that this is random. Okay, it's random because the outcome is not something that is going to be constant, it's going to change. Okay, if you roll a die now, probably when you roll it again it will change. Okay, so now if you define something that, okay, now your interest, because there are a lot of variability, so probably your interest is looking at looking at the number of even numbers that will be possible in your experiment. Okay, then the number of even numbers, remember that is going to be random depending on the persons who are going to perform that same experiment. Okay, so we say that is a variable, but because it's random, we say it's a random variable. Okay, it's a random variable. All right, now let's look at a sample space. Okay, so whenever you are performing an experiment, there is that sample space, also known as state space, okay, where the outcomes are coming from. Okay, so if you are performing a random experiment like tossing a coin, okay, then the sample space is just having a head, all right, or a tail, having a head or a tail. Okay, so these are the possible things that can come, or outcomes that can come out of the experiment. Okay, so we say that the state space, the set of all possible outcomes of a random experiment. So whenever you're going to perform an experiment, there should be that state space where the outcomes can come from. Okay, all right, so you are going to toss a coin, or you are going to roll a die, then the possible outcome, all right, the set of all possible outcomes, the set of all possible outcomes, is going to give you, let's say, 1, 2, 3, 4, 5, and then a 6. Okay, so these are the possible outcomes that can come or can happen as the experiment progresses. Okay, so random experiments like toss a fair coin, the state space is just a head or a tail. Okay, so either you get a head or a tail, right? So we're trying to define this x such that omega is mapping to r. Okay, so you want to assign you are assigning some numbers, okay, to the outcome. So you are saying that, okay, pick an element in omega, which is the state space. So if you pick a head, assign a 1 to it. If you pick a tail, assign a 0 to it. Okay, so this is like giving the outcomes a measure. Okay, you are now giving the outcomes which are coming from, or the possible outcomes, the set of possible outcomes, you are giving them some measure. Okay, all right. So random experiment like you toss a coin twice. So when you toss a coin twice, what will be the possible outcome? The set of possible outcome when put in a set is called a sample space. Okay, so take note. All right. Now when you toss die 2 times, there's going to be a lot of outcome. So this is just a simplified version. It means there's going to be a lot of pairs, right? If I should expand this for you, it means that you are going to have a row, you are going to have, let's say, a table. Okay, a table, and then on the table you will have okay, on the table you have this, Oh, wrong table. You have a 1 here, so 1, you have a 2, you have a 3, you have a 4, and then you have a 5 up to a 6. You still have the same thing here. 1, you have a 2, you have a 3 up to a 6, and then you draw the table. So you have a pair, so you have 1 1 here. All right, you have 1 2 here. All right, so that's what has been done this way, that there's going to be pairs I and J, where I is from, it can be 1 up to 6, and J can be 1 up to 6. So this is just a simplification of what will happen in this table. Okay. All right, so the other thing is event. Okay, now event is your interest. Okay, so when you are performing a random experiment, there are a lot of possible outcomes, and those possible outcomes are what we put them in a state space or a sample space. Okay, now what is your interest? So a group of possible outcomes we are interested in. Okay, so when we are tossing a coin, maybe you are interested in getting let's say an odd number. So getting an odd number is what your event. That is what you are interested in. You want to get a 2, that's your event, that's what you are interested in. So event is what the person who is performing the experiment is actually interested in. Okay, so what you are interested in forms the event. Okay, so you roll it, and then rolling a prime number is your event, odd number is your event. Okay. All right, so basic properties satisfied by the probability occurrence of an event. Okay, so if A is an event, so A is an event which is coming from a state space. Okay, then by probability theory we are saying that the probability of A should be a positive number. It should lie between 0 and 1, so it's a probability. And then the probability of A should be equal to 0 if that event you are talking about is impossible event. So you are tossing a coin and you say that you want 1. Remember, there's no 1 on coin, so that's an impossible event, so that probability should give you a 0. And then probability of A equal to 1 if A is certain event. Okay, so if the outcome of the experiment is just a 1, and you see what's the probability of getting a 1 is certain, so that is sure. All right, okay, so that is what we have for the first video. So we'll do the second video, and then that will be that. We'll